Hello and welcome to Unprofessional Engineering, Day 2 from Accelerate 2018. My name is James.
And you got Luke.
Luke, today we're starting the day off with Rafael Hostettler from Roboy. Welcome.
Hey, thank you.
So, having fun so far?
Yeah, it's amazing.
It's amazing?
Yeah.
Is that something that you have to say, or it's actually good?
No, actually, I was listening to a bunch of talks and I got odd, and I was like, fuck. Now I'm intimidated. I haven't, and then I was improving my talk overnight. So.
Fair enough. All right, before we get started, we're going to do a little bit of fun here. Some icebreakers,
And we call this like, would we be friends? So if depending how you answer these questions would determine if we would hang out outside of doing an interview with
That's about right.
Yeah.
Yep.
So first one, favorite engineer, designer, or scientist? Living, dead, doesn't make a difference.
So it's either Tesla, because he was just a crazy scientist.
Yeah.
Or the one guy that does Tesla now, which is Elon Musk.
Isn't that funny?
Yeah.
Okay.
Yeah, it's amazing. Like one person driving this crazy hardware startups, and everyone is like, no, it's not going to work. And he's like, I don't care. So
he gets a lot of hate. I'm surprised by how much people rip on him, because
Me
I think
too.
he's doing cool stuff.
I think people thoroughly have no idea how hard that stuff is and how hard it is to have a company afloat. And I mean, he has like $3 billion companies, so it's crazy. I mean, I can't once you trust. I think once you become an entrepreneur, you have to stand back in awe at the amount of things he gets done.
You have a whole new respect for him. Yeah. All right. So if you weren't doing this job, and we really need to change this because everyone here loves their job.
So-
if you weren't doing this job, what would you do?
And you can't say this is my dream job. You got then it would be your second dream job.
Yeah.
after
What's
that.
the second best, if not?
That's a very good question. So I built robots, so that's already.
That's
You have to change the question. I agree.
Yeah.
That's kind of a dream job.
Yeah, that's already quite a dream job, being paid to play with technology. Good question. I don't know. I think I would want to be a scientist in a different field, like biotechnology, like working with CRISPR-Cas, something like that.
Okay.
Because it's kind of like robotics, but just messier. So
Okay. that
Okay.
not
works.
about as transformative. So
Okay. How about, in your mind, is Pluto a planet?
I'm not going to take a proper stance on that. The problem is we kind of screwed up the original naming because we didn't know there were so many similar things to Pluto. And now we either going to have thousands of planets in our solar system, or Pluto can't be a planet. So
The reason this question is on there is I grew up. I'm much older than James.
You're very old.
And I grew up with Pluto as a planet, and then Neil deGrasse Tyson basically started this campaign to make Pluto not a planet. So we're just trying to gauge that. But
so you're angry at him.
yeah, a little bit.
You feel the loss of.
I do feel the loss
So
of
would
Pluto.
you prefer gaining hundreds of new planets?
No, I wouldn't.
I mean, that would make prime school a lot harder.
yeah,
really
it would. It would.
Luke
Okay.
actually has a rivalry going with Neil deGrasse
Yeah.
Tyson. He doesn't know it,
No.
but
Oh,
Luke's
no.
fighting
Yeah.
the good fight. So one more. You want to take
Yeah,
it?
last one. Rank these in order: Harry Potter, Game of Thrones, Doctor Who, and Star Wars.
Oh god. So it starts with Doctor Who, definitely.
Okay.
High up.
You're the first one to pick Doctor Who as
Really?
number one.
Oh,
That's
God.
pretty
You're
good.
up. You know, that's their jams.
That's so Doctor Who is
Okay.
just amazing. It has the right amount of craziness. The other three like that.
Okay.
Followed by Star Wars.
Okay.
And then we had Harry Potter, Game of Thrones.
Harry Potter, Game of Thrones.
Tough.
Do you watch either one?
Well, I have both, but I think I'd go with Harry Potter first.
Game of Thrones last.
Yeah.
Wow. That's like the opposite of.
Is it I dislike Game of Thrones or I
No,
like
not
the
at
other
all.
three
no,
that
I
much?
like the other three that much.
Okay.
No, I mean, I'm a big fan of stuff that's impossible, and I think Game of Thrones has the least of that.
Okay, fair enough. I've never actually seen Doctor Who, so
Oh, you missed out.
I keep
You
getting
did.
told this.
You did.
God.
All right.
You should go home right away and watch Doctor Who.
Cancel the rest of your day.
Yeah.
Go home and watch Doctor Who. Okay, so moving on to the actual questions. So for those of us who might not know, what exactly is Roboy?
So I think first of all, Roboy is a vision. It's basically the vision of creating robots that are as good as the human body. And of course, to do that, you have to have a great team. And then, so second, it's a huge team. And then third, it's an actual robot. And what makes it Roboy very special is that we imitate the human body. So it's not a robot like you would see an industrial robot that has like motors in the joints and so on. It's very stiff, but it's like a robot that has muscles and tendons. And we try to understand how we as humans do actuate this, how we work with these muscles. Because if you look at the human body, it's just a marvel of engineering. It's like orders of magnitude better, and one wonders, why do we build robots like that and not like this?
That's a good one. So yeah, so following up on that, so how is it different than like you just said, traditional? So you mentioned that there isn't like a motor in a particular joint. So how does that joint get actuated and turned?
So,
if you can go into the detail.
Ideally, we had a material that works like human muscles,
okay,
because that's just a crazy material. If you think about it, like a fly and a whale both use more or less the same type of actuation, and it's the same thing. It's just
obviously
a thing of scale. And,
yeah.
And like having a material that sort of brings force wherever you want it at whatever scale you want, that's wow.
Okay.
But we can't have that yet. So and this would be, it's a field of its own, and there's tons of labs working on different technologies and how we might do that. So what we do is we focus more on, assume you have these muscles, how would you build a robot with it, and how would you use this to create robots that behave like the human body and then do control on top of that. So far right now what we're using is electromotors that are sort of coiling up a tendon, and then there's a spring inside that makes it soft. But really, we're not in love with the technology. It's just right now, it's sort of the sweet spot of works well, is relatively easy to build and maintain, and actually safe to use. I mean, there's other technologies like electroactive polymers, for example, but typically they use voltages in the range of thousands of volts, so you won't have that at a fair and have children touch it. It's like,
let's go play with Roboy,
that's
mommy.
probably good.
ow. Yeah. So.
I think we've touched on this a little bit, but what are some of your short-term and then more long-term goals for Roboy the Vision and Roboy the Robot?
So I mean, having a vision like that, it's like a 50 to 100 years. I don't even know how long it's going to take. So what
it's job security. 50 to 100 years. We're good.
Yeah. Well, I plan on living forever, so it's not that long.
Okay.
That's good.
That's a good goal to have.
No, but I mean, so what we do is we break it down into half-year visions. So we just completed Roboy DJ, which was like the idea of that you as a user would wear a head-mounted display from his wife, and then you play on a virtual xylophone in VR, and then the robot actually plays the same thing that you play. So this was the vision. This was the first vision we wanted to achieve with Roboy, and we're almost there. So the vision for the next half a year will be that you stand at the underground station at the other campus, and basically you just text Roboy on Telegram and be like, "Hey Roboy, can you pick me up?" And he drives over from the lab, picks you up, and brings you to the lab in a rickshaw.
That's crazy.
And while this and so on, and then it goes on, and then so the roadmap right now goes to 2024, where we want to fly to Mars with Elon Musk, of course.
Of course.
But so the idea is making it progressively harder with every half year.
I think you're taking pretty big jumps.
Well, I mean, it's not, we don't go to, we can sell this as a product. We go to, we show it somehow works. But it's actually interesting. So we have a lot of discussions about, do we actually cut corners? Because you could cut a lot of corners.
And make things happen.
Yeah, we're like, actually the robot is not steering. You have like a servo that does the steering for you and these kind of things. And what we decided is like, we will only cut corner where it doesn't sort of, doesn't jeopardize the robot. So it will be the robot steering, but with his hand. And
So you talk about jeopardizing the robot. I think I saw you have an interesting title for Roboy. So you talk about like making sure he's safe. What's the title again?
So I call myself the legal guardian of Roboy.
Okay.
So I just get to say what he does.
And what does that mean?
So it comes from the original Roboy, which was built by another team that I sort of adopted.
Okay.
So then I became the legal guardian.
It's fair.
And it's now, since we have a new Roboy since March, which was actually sort of built fully on my ideas, and there now I call myself dad because, as a father, typically you're not so much involved in the actual building process, but much more in the idea of, of the result.
Do you hope the original one someday calls you dad?
That would be weird. No, I think this anthropomorphization is very helpful to make it more relatable, and we do a lot to make it really like safe, and people like try to take away fears that people might have when they interact with the robot. Because we think it's very important that people understand where we actually are in robotics. Because you see movies like Star Wars or Star Trek and so on, and then the robots there are like humans and or tin cans, but they are like on a level which is not where we are in robotics. And then people come with these crazy expectations, and then they see a robot for the first time, and then they're super disappointed.
I gotcha.
Yeah. So what we try to do is, of course, we can't be better than state of the art, but at least we try to be funny and entertaining, do bad jokes and things like that.
That kind of rolls into the next question of how do people actually interact with Roboy? And so what are some of the things they can do? And then the first time they see him?
Roboy,
is it like,
right?
Yeah.
Is it like they touch him and they talk to him?
So typically people are afraid of touching the robot, but it's more like they don't have a good idea of how fragile it is, and they just don't want to break it.
Right.
And then if you tell them no, it's fine to touch, so you get a whole spectrum of interesting soft touching to robots, and then like
you're like, don't touch that much.
Yeah, but actually it's very, very robust. So that's the nice thing about this technology, because we have these springs in the muscles. It's extremely robust against sort of external manipulation, and much more than you would get from traditional robots. So that's really a gain. It's also one of the few robots like we don't have like a safety barrier around it.
Right.
Never do. But it's quite strong. So the motors pull up to 500 newtons. So that's 50 kilograms. So you could.
Wow.
Is that like 3 pounds?
Something like that.
Yeah.
Yeah. Like
We're bad with the conversions.
yeah, it's like I don't know.
50 kilograms. What's that?
It's
2.2, something like that. So
150
100.
pounds?
Yeah.
100 pounds, something like that.
Okay.
Cool.
So how do people actually? So is it speaking? Is there verbal communication between?
So we do full stack robotics. So we do the mechanical engineering, we do our electronics, but we also do our control and our dialogue system. So we have a rather big team that is actually working on the cognitive side of the robot, trying to build a dialogue system, and it's basically a mix of a chatbot and sort of a rule-based system. It's quite sophisticated, like using different tiers, using some natural language understanding in the beginning to figure out if this is something that it can answer rule-based, and if not, it tries to query some databases. You can ask him, for example, about the weather and these usual things you can do, and then we have a neural network as a bottom layer, so it always answers something, and this is usually the most entertaining part, depending on what you train it on. We had them for a while. We used the Twitter data. We had to stop it because people kind of rude on Twitter. Yeah. So now we use films, like subtitles of films.
Okay.
It's very good training data.
Okay. So
Training.
I guess the question I would have is, why is something like Roboy, this non-traditional robot, like why is that so important for the future of robotics versus, like you said, what I think of a traditional robot, a tin can? Why is this?
So we want to have robots that are safe to interact with, and there's other methods of doing that. But I think having a robot that sort of functions in its passive functionality like a human body is this very natural thing to interact with. You have like 25 years of training on how to interact with humans, but you have like maybe a few weeks or days of training how you interact with a rigid system like a robot. So in that sense, if you have robots at home in 10 years or so, and you want to go to the fridge and pick a beer because the robot is doing the dishes or cooking, you want to be able just to nudge him away as you would with a human, right? But like if it's a steel robot or a classical robot, and they might not register you, it might kill you, and it's not the way you want to have a robot at
I
home.
sure
right?
hope not.
Not
so
feeling good
that's-
about this.
So that is one thing. And then on the other side, but that's more academic, having a robot that is close to a biological system is very interesting for people that work with any kind of, that try to understand the human body. So for example, neuroscientists that try to understand how we generate motions, how we do the complex, we were pretty good robots again, and also the control of us is pretty good, and people want to understand how that works. And having robots that are closer to that is a very interesting thing and very useful to these kind of people. It's also why we are part of the Human Brain Project, which is this huge European research project on trying to create the infrastructure that's required to sort of understand the brain.
Wow.
Yeah, that's deep.
Sometimes we talk to people that are just so much more intelligent than us.
Well, than you
that
mostly.
Than me, that it really hurts. So let's talk about the design and manufacturing process a little bit. So a lot of Roboy is 3D printed.
Yeah.
Why was that the direction you went?
Because it's fast. So we really try. So basically, we try to have 3 types of parts, off-the-shelf parts, parts that we can like manufacture in one step. So for example, the bones are extrusion profiles, and we just cut them to length. But that's very flexible, very fast. So you have to change like the body properties of the robot, and then the rest is supposed to be 3D printed parts because this gives us the geometrical freedom. And sort of that's a perfect combination. Like we can get strength from different materials, and then from 3D printing we get the geometrical freedom, and then the standard parts are like there for complex functions. But they exist, they're being produced by the millions, so they're easy to obtain.
So
It just makes us faster.
So if he just like fell down the stairs, you could just print him a new arm if he broke it.
Yeah.
That's
And
kind of nice.
That's where we want to go, right? So really I want to get to the point where we have push button robotics. So you design your robot in your CAD or in your robot design software, and you press a button and it walks out of the printer. That's where we want to get to.
Sure.
But that's like the challenges there's still a lot of challenges.
When you're going to live forever, though, that's not a big
you
deal.
got all kinds of time
Yeah.
to figure it out.
I know, that's why.
Okay.
So I heard that I think it was the hips were generatively designed. Tell us why you went that direction, what your experience was using that for that particular application.
So of course, and first and foremost, it was curiosity bound. But like having the opportunity to work with new technologies, and then the question was, what is the most the part where we can show the most that this is a useful technology? And we went for the hip because right now Roboy sits on a tricycle, so the hip is where all the forces connect, like from the torso, and like when the robot does this, you get like these huge moments from the spine, which were in the hundreds of Newton meters, and then you have the force from the top. The robot is quite heavy. Then you have the forces from the legs and so on. And in robotics, it's very important that you have lightweight parts because you always have like the further out you have the problem with lever arms, right? So every gram you have here, you need a 10-fold force if your lever arm is very short. So being able to produce lightweight parts which are able to sustain very complex load cases, and the hip is the one which has the most complex load cases, was a very interesting challenge. And so we were able to do that, and it's super fast. So from we get the software to we have it printed in the robot, it's 5 working days.
Wow.
Including learning how to use the tool. To find
Including
load cases.
learning how to use the tool.
Yeah.
Wow. It must be an easy to use tool then. Everyone
actually.
could use
Yeah,
and
yeah, it's
understand
very
it.
simple.
And it's actually installed on on Roboy now?
Yeah.
The hip?
Yeah,
Okay.
yeah. We actually use it.
And what was it printed out of? Was it a plastic or did you do steel?
No, we use plastic.
Okay.
So it's polyamide.
Okay.
PA220, I believe.
So I have a quote that I pulled from your website. We build new technology, thoroughly test it to the point it breaks, learn from this failure, and start building again. How has this helped in this design process? If that's actually something you guys follow along with, how often is this the case? What do you learn during this process?
So, I mean, we break everything all the time, of course, and it's robotics, so everything fails all the time.
You're really selling me on this. Okay.
Yeah, I mean that's just how robotics is, and I think that's how physical things are, and I think this is also it's very very hard to understand like how things interact with each other in the real world. So for example, I mean you can simulate loads for parts. That's easy, or it's now made easy. But how this part then interacts with the torso, and when there's external forces, you can't think of all the load cases that you might have. It's maybe too hard to foresee how friction will influence the part over time. It's hard to so it's a soft robot, so we have all these soft things in there, like it's going to have a soft skin, and it's going to have well, the springs make it soft as well, so you have like things like friction in the system, you have things like wrapping, and so you have all sorts of these effects which are almost impossible to model, to simulate. So simulation doesn't only get you to some point, and then I mean of course we first simulate what we can, but then we basically have to try and learn from that. So we do prototype a lot, we break very fast.
Very fast. Could you go into a little more detail of what a soft robot is?
So basically, it's any robot that uses soft materials inside, or has a soft behavior, like dynamic behavior. But it's a very new and nascent field. So right now it's very exploratory, which is cool because you can people have ideas. So most papers in this field right now are idea papers. There's very little sort of, methodology where you're like, okay, now we have sort of solved how this works. And it's some for maybe for pneumatics actuators it's there, but for many other things it's not. And then people do all sorts of crazy things. There's like one lab that builds soft robot which work like balloons are being blown up, and then they sort of can use this, and it's basically just a very very open and free way of thinking. But if you look into nature, everything nature builds are soft robots. There's almost nothing, like everything has soft components in it. Even like ants and bees, or they have exoskeletons which are quite rigid, but despite that, like the muscles they use are soft and so on. So nature builds only soft robots. And if you look, for example, at an octopus, which is like a purely soft gel-like thing, but they're crazy. Dexterous, they can even open jars and do all sorts of crazy things. And I think it's very interesting to look at how might we deal with these kind of systems, how might we build them, but also how might we control them. And that's probably one of the main reasons it's so nascent, is that we really have not a good idea how to control these things.
So I'm sure you've seen the videos of the Boston Dynamic robots that do backflips, and the scary dogs that look like they're gonna they scare me a little bit. So I guess the question is the robotics world, like Boston Dynamics and other folks doing, is it competitive to get to a point? Is it collaborative? Is there sharing? Is it what's the relationship with folks like that?
I mean, Boston Dynamics is a company, so they're notoriously a bit harder to work with, and we don't have a collaboration with them, for example. But like in the research world, it's quite open, and there's a lot of collaborations and throwing ideas around. It's relatively easy to talk to people, and although robotics feels very very big, once you go to conferences, it feels kind of small. So there's it's not so many people you need to know in the field. So I think it's quite. I mean, of course, it's competitive as well. But not in a negative way.
Okay.
So you would never see someone trying to go and steal something from another one. So
It's more one-upping each other, trying to get there quicker, trying to come up with a newer idea.
Also, especially in soft robotics, it's this battle of ideas. Who can come up with the most crazy and interesting thing that shows that with a soft robot you can actually do something much better or much easier.
Okay.
Are there any ethical concerns for development in the future?
So I think it's a twofold answer. Like on building these robots and improving them over time, not really, because it's very far away from having a huge impact into society, and it's also hard to scale. And I mean, at the end of the day, despite it being a robot, it's a body that's being controlled. So like it's not, it doesn't have the potential of doing something super destructive. But on the other side, and this is I think where we should really talk about the ethics behind all of this, is we're doing a lot of automation, and I know especially here in the US and in Canada as well, there's this idea that automation will be with it will basically augment humans, and but I think what we'll see is a lot of jobs, especially not necessarily hard, like physical jobs, but a lot of software or structural functions in company. I think we will see them go away. I think lawyers are actually in pretty deep trouble.
You're in trouble. Better call the wife.
I mean, a legal clerk. That's something where we have now AI algorithm that can basically they outperform. There was a test recently. It was crazy. They were verifying 70,000 contracts, I believe, and they had 2,000 lawyers and one algorithm. And after 2 days, the 2,000 lawyers, they had like checked for a few thousand of the contracts, and the AI was through after 48 hours. 1 and 2, it was actually better. So it caught more of the sort of the fine line things that needed to be understood about those contracts. So that's huge. I mean, this is like millions of dollars that are invested in such things.
Interesting.
So I think we should really talk about and understand, okay, what do we do, or assuming that we will automate away a lot of the work that needs to be done, how do we handle this as a society? What do we do with it? I think that's very important to talk about. And maybe there's a 10% chance, it's only a 10% chance that it happens, but I would really want to talk about anything that's a 10% chance of disrupting society. You know, I mean, it's fine. Maybe we're lucky, and there's a 90% chance we're going to be lucky because we tend to be. But there's this other 10%, and we really should talk about that and figure out how do we do it. What is the solutions? Is it like basic income? Is it a modification of that? What is it that sort of makes sure that we're going to live? We sort of cross this chasm from this scarcity world into post-scarcity world.
Okay. So you mentioned going to Mars with our good friend and longtime listener Elon Musk.
Yes.
What are some of the other kind of interesting milestones? You mentioned the rickshaw, your text to give you a ride home. But what are some of the other intermittent goals that you'd like to accomplish that are interesting? You have to go through all of them, but if you had a handful that were interesting.
So I think one which is kind of interesting is the carpenter, because that's the first time we're going to show tool use. And it's actually quite late because we wanted to be able to sort of build a stool on its own, but from scratch. Mm-hmm. And that's very interesting because you need to have a lot of things done right, and you need to have a very good understanding about your robot to actually showcase that this is possible. And we're already talking to companies. Like, it was really interesting. That was one of those things it's on the roadmap for in 4 or 5 years, and we already been approached by companies like, you have seen it on your roadmap. Let's talk.
That's funny.
I like that.
Yeah, so I think that's an interesting one. Then, of course, right afterward, it's about Roboy building Roboy, like the idea of a robot that sort of built themselves.
Like fixing his own leg.
Yeah, exactly.
Okay. That's our last question, I think.
And then earlier ones, I mean, we're looking into something which is more dialogue system heavy, which is called the Roboy, Dr. Roboy, where the idea is that the robot does a full diagnosis, and there's a lot of interesting things. For example, if you look at stroke, there's these tests where you have patients move, and we could have the robot run these tests of the patients and so on, and use AI to detect what might be the problem and so on.
So one last question, and it's probably the most important, I think. Are you afraid of robots taking over the world? Because this guy is not feeling real good after talking to you.
As I just said, I think should we be afraid of like superhuman level AI that is by accident destroying the world? I think there is a non-zero chance, so we should really look into this, but it's not like in the percents, so it's hard to estimate anything, but I think the chance is relatively slim. And I think the big hype around it is dangerous because it's kind of overshadowing the actual problem we have with automation, namely that it might, with a much higher chance, disrupt the structure of society because we will put like millions of people out of jobs. And I think that's the real thing we have to talk about, and that's where I see the real danger, because I mean, well, we're not in the US, but they voted for president, and that's in my opinion, it's sort of an artifact from this transformation, because people are afraid, and that's when these kind of people start becoming successful.
Okay.
All right. Well, I think that's all. We actually have to wrap up here. So thanks for joining us today, taking a little bit of time to talk about Roboy and where things are headed for our future with our robot overlords.
Thank you so much.
If you need to hear or want to hear more from Roboy, check him out on Twitter at Roboy Jr.
Thanks.
All right. See you guys
See
later.
you guys. Thanks.